Oh. Went straight into just a random live stream, okay. Let me edit the title. Oakley dokley. Let's view a channel. Get a link. I need to restart Spotify because Spotify is broken. Great. Turn off OBS preview. Okay, I haven't looked at this in a few days, so I have to reassess where I'm at, what I need to do. Put this into here as well. What's YouTube saying to me? It's saying that I need to increase my bitrate, okay, to 13,000. I haven't streamed in a while. I feel like 13,000 is high. 13,000. Fine. Okay. Let's just quickly restart. Okay. Stream settings, analytics. Cool. Okay, I think we are all sorted and working. Am I peaking? That volume. Okay, now we can actually get on with work. Okay, so where are we at? So first job is work on the idle hand position. What else do we need to work on? We need to work on idle hand position. We need to work on walking, and then we need to work on the stability of the lower body and try and improve the jiggling of the head. Those are my key things. Let's write those up. Yeah, so first, idle and position, walking, and then we need to work on hip ability. Is there anything else we need to work on? Those are our key things. Okay, so first things first, let's have a look at our animation blueprint. Some days, see if we can get that going. This isn't just well. What playlists do they have? A little bit more chill. Okay, so this is the blueprint we're working on. Has basically nothing in it. Animation, arms, and Edric body are now separate. So on this one, let's set our preview asset to Edric arms only. As we increase our speed, we do have the walking animation, but right now, because the arms are now attached to the camera, when the camera turns down, this walking animation is happening like back here behind the character. So what we need to do is create a new set of idle animations for just the arm. So I think I want like animations where I just got the hands like naturally down there in front of and your that. I need them like this. Okay, animation offsets. That was the whole point of this new system, was remove those. Maybe it's fine if it's just like a base animation offset. Okay, let's get our animations up. So full body animation. We get our base idle animation, standing idle. Duplicate this. Actually, let's make a new folder. New folder, FP arm. Which we just made. Idle. Idle. Damn it. Never find the thing you need when you need it. It should be a underscore copy. Here we go. Standing idle. Standing idle, standing idle. Standing idle copy, okay. Put this in folder. Create some sort of management. Otherwise, we're going to go crazy. So we'll do this standing FP idle. And let's see what we're doing. Log me out. Not my monitor, so you don't leak my emails. If I can remember my login details for Maya. Third password's the charm. Let's go. Okay, we need the asset reference. So in here. Drive. Edric. Body. Okay. There he is. Man, the myth, the legend. Looking great. Load. Okay. Let's just use poses for the moment. So Is the pose the best way to do it? Because otherwise, are the walking animations work? Are they going to work? We don't have to make new walking animations. I bet you think more intelligently about it. How do you use a bone offset? Because I've got the amount that the arms are looking down, right? So if I just take this, here, and I get 2 local to component, do this, and then do a bone offset. Modify bone, transform. And if I modify, which bone am I going to modify? Bone to modify. Let's modify, not the root, not the hips. It's going to be somewhere up the spine. We like take the chest and we actually rotate the chest itself around, then maybe we don't have to do any more animation work, and that'd be good. The more procedure you can make it, the better, in my opinion. Especially when you don't have a full-time animator, and I'm your animator. Okay, so let's open up the skeleton and have a figure out which. Actually, let's just do it. Which bone are we going to edit? So on our root, it's going to be somewhere up our spine. Look at our bones. Oh, we can't see them. Okay. So somewhere up our spine. So chest, I think, is the one we want to rotate. So chest _ M is the bone we want to actually move. Okay. So bone to modify. S. The warning. Transform mode, no components to modify selected. Yeah, sure. There's no let's try and add to an existing. We want to add. We basically, like, as we look down, we want to rotate our arms up, and as we look up, we want to go back down to neutral. So we want to rotate between. So if we just for the moment just put it as like -90, and then yeah, so now our hands are always on the screen. More what we wanted. Right, I don't want it to happen to that hand. So in our first person animation loop, also this is not, it's not going to be a static number. This is going to be a variable that changes depending on how far up and down you look. So let's make this a variable. Let's let's split this. Split struct bin, and it's the X rotation we want. So we'll then promote this to variable and say idle arm offset X. And we'll figure out why it's doing it also to the other one. Ah, it's because we're modifying a bone that's further down the chain. Ah. That's a future problem. We'll figure out that problem later on. But let's get it looking right on the idle stuff first. How are we going to do that? Maybe we should do it to the clavicles then. Let's quickly see if we can, because I'm foreseeing a problem. If we do it with our like add to existing and we do it to our clavicle head, not there. That is scapulas. Sorry. Shoulder. Make this 90. Minus. See? That achieved the same thing. We change this from shoulder R back to so many face joint. Back to the chest. File, save. Okay, that does work. So we can do it individually to each arm, which means that it should be replaced when we have our holding animations. Excellent. Exactly what we want. So what we do can happen to both shoulders. And if we plug this in both of them, modify it. Not scapula, shoulder. Shoulder R. That to exist. L. Okay, so do that. And then let's say, for example, we are holding something. So our arm's up here. And then our arm offset, we'll put this to minus 90. This one now doesn't do it, which is correct. So this is still on screen in the right place. We can now move our other arm individually, you know, put this into the right position by just like editing this value, which will edit based on a value in our thing. Blueprint one. So in our event graph, get pelvis tilt. This is our look pitch. So we've already got the angle in which we're looking. Maybe we should print that out and just see what we're saying. So if we print this out, let's just see what it's saying, and we can figure out what to do from there. Because if I can make the procedural, that'd be top notch. So as I look down, I get to minus 90, and when I look up, I get to 90. So for the moment, let's just plug this value straight into our thing. So in our run state, instead of using this, we'll get our look pitch and plug this straight into here. So when it's 0, you look straight forward. And let's just see what it looks like. So when we're looking up, what are we doing? Okay, our hands are now always in the right spot. And then, for example, if we go back into the body and press E, our arms are in the right place. Of course, we've got some oddities here with like, because the shoulder is in not the right place because it's attached to the camera, it looks odd being like this. So there might need to be some edits and stuff to make that look better. But in theory, the system works, and that's all that matters. Once you've got the system working, everything else can be dealt with later. So that's good. Exciting. If we go full screen, it'll look better just because you're further back. So when I'm running, my hands are on the screen. Hands are there. This is progress. This is good. So now I can create some mathematical solution to figure out what should be where at what time. So when I'm looking down, the hand's in the right place. When I'm looking straight down. Yeah. When I'm looking straight down, the hands are basically in the right place. Although there's probably some transform stuff I could do. Like, once we got this translation thing working. So our look pitch. Now, this maths, how am I going to do this math? For the moment, I think I'm just going to do the maths. So if we get our look pitch, we have this pitch, which... yeah, this one. I want to convert this into a 0 to 1 space first. Because once I have it into or maybe even like -1 to 1. So 0 straightforward, -1 down, +1 up. Because I want to use it as an alpha. So let's do a remap. No. Map range clamped. So minus 90 to 90. Remap that to minus 1 to 1. And then we'll promote this value to our idle arm offset X. So now we've got a minus 1 to 1 value that we can now use to plug in some values and sort out our arm positions when we're looking up and down. That makes sense to me. Don't need this. So on the rotation, when we're at 0, we want nothing to happen. So let's get a blurb. So actually, let's do another map range clamped. So at minus 1, we want this to be minus 90. And at 0, we want this to be 90. So this is what this is how we had it before. This is how we had it just now. No, dude. That's what we just had. How do we want it to actually change? So what we want is when you're looking up for it to actually be greater than 90. I think. No, that's fine. This is what we want. But I think we also want to do some translation. So if we do another map range, if we do translation, just quickly reselect previous instance. If we just back to like 10, oh, I want to make sure that we're moving stuff in the right direction. It's because I'm not component space, add to existing. We want to do the Y. So 0 will split this in, and on the Y, we will add like minus 10. So now we can pull the arms back when we're looking down. And let's do another map range. Plug this into both translation Ys. And this is our main value. And it's going to map the range between, let's say, when we're looking straight down, which is minus 90 or minus 1, we're going to move the arms back 10. And then in range B, when we're looking straight forward, it's 0. I think that makes sense. So as let's just play it and see. That work? Okay, let's make the values bigger so that we can see an obvious change. Let's make it minus 100. The arms probably won't be on screen right now, but we'll be able to see. Okay, so they're moving it up. Is that because the component space is actually rotating around? If we now look straight up, we're back into the correct position. Okay, we're back into the correct position here. That's good. But what we want to do is when we're looking down, we want to pull the arms back slightly. Make everything line up more. Maybe it's not the Y we need. Let's try plugging it into, I don't know, X. FA out. So now we're moving over here. Z? It can't be Z. Get me all confused, game. I feel like... Okay, so that's moving in the right direction. If I go to neutral, so looking straight forward, back into the right place. If I look like halfway down. Yeah, see, we're moving at a diagonal. Actually, that's fine. That's fine. We can move a diagonal. That's not a problem. I think what we do is we just bring the values back to something more reasonable, so 20. Then keep look down, and our arm should be about the right spot. Probably a little bit too far still, but I think that looks nice. See how it looks when we're walking and once it's on both arms. For some reason it's only doing it on one arm. Why is it only doing it on one arm? It's plugged into both, right? Shoulder L, shoulder R. Make it minus 15. I'll save. Now if we just test out our arm offset, so if we make this -1. Route node here. We can make this look cleaner. Are they moving in different directions? -1. No, it's just only happening to one arm. Ah, it's because I haven't... Oh, God. I'm sorry. Add to exist. There we go. Now it's happening to both arms. Nice. Now we'll compile save this. And see how we're looking. Then if we press E to interact with something. Still all in the right spot. Run. I actually think we might want to bring the arms up a bit so that when we're running, see our hand like in the corner of our, you know, like popping up on the screen a little bit. Because right now, as we look up, we're keeping our hand down here. Whereas what we can actually do is probably actually allow that to come up a bit. But what's the maths we're going to need to do to make that happen? I think the maths we're going to need to make that happen is as we look up, which is this rotation here. So as so at the moment of 0, this is 0. Actually, what we want this to be is get to 0 when we get to the top of our look. Maybe that's not right. When we're running, this looks nice, but when you're standing still, it looks weird that it's like shifting at the bottom of your screen. When you run and how you can see like the look up, you can just see your hands bobbing around like that. I think that looks really nice. Interesting. Yeah, it looks really nice when you're running. Maybe we can make this value edited by speed, because when you're idling and you see like you look there, my hand like wobbling around at the bottom of my screen, that doesn't look good. But if we put it back to how it was, back to this being at 90, so sort of trying to perfect the position. This looks good, like because your hands do shift a very little bit when you do like that, but not so much that it actually like you notice it or it bothers your eyes. But then when you run and you look up, it's a bit boring not having like the hands hitting the bottom of the screen. I think that would look nice if they were like the bottom of the screen. So I think what we do is we create a multiplier for this. So this outrange B is edited by speed. So as our speed increases, we allow that hand to come up a little bit, and as the speed decreases, it brings it back down into the correct position. That's how we'll do it. I think that's the smart way to go about it. Is that the smart way to go about it? I like it as procedural, not adding any more animation work. I think it will make you more connected to the character, being able to see your hands a little bit more as you're running around the world and doing stuff. So, yeah, I think it's a good idea. So we've already got our speed value here. So if we get our speed value, And what is our current blend space values? So if we open this, so 400 is our maximum run, and we start sort of walking at 200. So what we want is between 200 and 400 alert between the idle and the running positions for the arms. So we need to get this outrange and lerp between 0 and 90 based on another map range. I always forget, is A1... We'll just figure it out. We'll figure it out in a second. The speed is the value, and it ranges. The speed ranges between 0 and 400. And at 0, we want the value to be 90, and at 400, we want the value to be 0. I don't like how the arms have moved. That's weird. The speed right now is at 0. So if we maybe go between 90 and 0 like that. Oh, we want it between 0 and 1. Sorry, that's what I'm getting confused. Then when our speed's at 400, I think this should be... Oh, maths. When we look down, our hands are not in place, but as we then move, our hands are still on the screen when we're running around, and then as we stop... Yeah, I think that looks really nice. Happy with that. Well, happy with that. And has this messed up all my swimming stuff? I can't remember. I don't know if this actually affects any of the swimming animations. Let's go and swim and see how it looks. It looks weird that you swim into the air like this. Maybe I should limit the angle of swimming animations. We'll figure out swimming in a bit. Swimming's a less important part of this. But now, like, if we're doing a potion ability, you can see it's always in the right place. You can see the hand when you're running, and then when you stop, the hand spot. Shadows all look correct. That's actually pretty close to doing everything I wanted it to do. Let's review. Idle hand positions. Walking in, like, the hand positions, which I thought was going to be the hard bit today, is actually already done. I guess this is going to be the hard bit. Hip and leg stability. Yes. So right now, when you like... Yeah, I need to create some more things so I can actually see the... Let's just... material. I need to create some more visual points on the screen, because otherwise my brain can't like see the movement. Create a few pillars. Need to like look around. Now, yeah. So you see now, when I'm like walking in little circles like this, this is what I want to fix next. My walk, run, blend space, and turning is ugly. This does not look good. So maybe I need to... I don't know what the exact solution is. I think what I want to do is get up at Epic Games Launch. I want to look at the dynamic first-person default thing. Because there's a good first person, or a good third person animation set up for that. Okay, my library's Because basically where we're going wrong is this. We open up this. Yeah, it's this blend space that's causing the problem. It's because the values are changing too quickly, so it's having to go from this value, like this value, immediately, and that. What if we just try doing some more blending? Smoothing time. What if we put smoothing time to like 0.3, 0.4 seconds? Vertical axis doesn't need smoothing time. Actually, let's put a little bit smooth. 0.2. Maybe this will just fix everything. That doesn't just... Let's put it back to 0 and just see what it looks... Remind ourselves of what it looks like. So we're going from full right to full left. Okay. Yeah, advanced locomotion system. Let's create a quick project saying this, whatever. 5.0, yeah, that's fine. Okay. Because I just want to analyze how they do it. Because this I don't know if it has a first person mode actually. I would have a look. When I don't understand systems, I don't know stuff, I just look at how smart people have done it, and then I just copy them. Okay. Fine. Running shaders. Is there a way to go first person? Nothing click. Camera's perspective. Hold C. Okay, so now we're first person. See this, like, there's no jerking even when you like, there's no jerking here. So clearly, something they're doing is smart, and something I'm doing is stupid. Because this camera is attached to the head bone, so any sort of bouncing in the head would be noticeable. Like, as I like run around in circles, the legs don't jerk around and do weird stuff. So what I need to do is figure out this system, which I've tried to do in the past. It's very complicated. But this is like a full foot matching system. I don't think I need a full foot matching system. Maybe I do. Why can't it just look like this? This looks so pretty. Anyone who does first person animations or animations at all will appreciate how like nice this is. Oh dear. Okay. Well, let's have another go at trying to figure this out. ALS and MB. Odd. So, okay. So this is doing some stuff to the spine. No, because the legs themselves are smoother. So if we go to our base layer, locomotion's main ground state, from roll, transition, standing, locomotion, base state, cycles, locomotion cycles. So walk, run. So this is different blend spaces for each direction. Okay, interesting. So this goes from literally 1 to 0, and then stride is how fast you're going. So walk, run is 0 to 1, and then stride. What does stride do? Oh, that figures out the speed. So Wait, what's the difference between walking and running are states? Yes. Weird. What's the difference between stride and walk and run? Because it's like the speed. Still on your running. Walking. Okay. Cycle. Tempo based on gait. Oh, so sprinting is just only 4. Sprint. Different thing, right? Yeah, so this is playing a... Yeah, okay. So I only care about these ones, which is base walking. Landing. So in each of these, so let's say like walk, run forward. We've only got a walk. Other animations are actually part of this. You've got run, pose forward, run forward. So let's look. Run forward is literally this, like this. And then what's the run pose for? I've used this sort of stuff. Just like a version of it, but it's just completely still, right? That's how you like make your legs move less and less and less as you walk slower and slower. Okay. That makes sense. That makes sense. So how do you actually cycle blend this? What is this cycle blend? That's a lean. We don't need a lean. So directional. Oh no. This is so... Oh dear. How is it setting movement direction? Let's find out how it's... Because that's an important part of it, right? Is you need to figure out which way you're going. So let's just find references. Set movement direction. Calculate movement direction. So it gets its gait. Calculate quadrant. Oh my god. Aiming rotation. Is that just character forward, I guess? Yeah. Just which direction the camera's looking. Calculate quadrant. Oh! Who would have thought animation systems are so horrible? Oh, wait, me. Because I know they're horrible. I'm not surprised in the least. Okay. This actually makes sense to me, though. You basically, what you're doing is you get your velocity, figure out which direction you're looking, and then directional states. What else? What else? So let's say you're running forwards. Oh, left forward and left back. These only get changed. This get changed also if hip orientation bias on feet crossing. I don't think we need to worry about feet crossing. I think that's too advanced for our game. Oof. But this is like figuring out, so if you're going diagonally that way or diagonally that way, creating a bias system. Whereas I think all we need to do is check which way you're trying to move. I don't think you do, because when I play, I hold C to go into the head. If I run this sideways, it'll start going this way. Then as I walk backwards, it does that. And then if I go sideways, it like crosses the feet. I'm running this way. And I turn around this way. I run backwards a little bit, and then it crosses the feet. That I don't need. That is a part of the system that I do not need. But maybe I do want... I'm fine with them crossing over as you start walking, rather than walking and then crossing over. Maybe it's cool to have that. Maybe that's what breaks up the movement and makes it look better. Also, like the head stays remarkably still. There must be some hip or neck stability. Have a look at the like base animation. This spine rotation is making... Or is that just rotating up and down? And IKs don't need that. 5Ks don't need no. Right? No, don't care about any of that. Post layering, let's just go straight into the IKs and see what gets disabled and what doesn't work. Does work. That's always an easy way to figure out what's happening. Yeah, so that actually... The stability of the head isn't actually being affected by the spine rotation stuff. That's just the look up and down stuff. That's fine. That's good. We don't need any of that. Already got that system in. We've already got that. Maybe all I need to do is convert what at the moment is a very simple system I've got, which is this blend space, which is a big blend space that I use for all the movement directions, into a series of regular blend spaces for each direction, which then get modified through the switching. I don't understand how that fixes the problem. Because if, let's say, we've got the locomotion detail. What the hell is that? I don't know. Motion states. Hit left. Yeah, I don't need running state. Moving. Hash poses locomotion. What is this locomotion detail? Never. Oh, so that's all this sort of stuff. Is this all additive? Yeah, this is additive animations. Okay, okay. I'm not going to stress about additive animations right now. Locomotion cycle. This one, which... Okay, so all I think I need to do is try and recreate a system like this. But what I need to figure out is how you fly, walk, run, we know how to get. Let's see how they're setting. I find references. Set walk run, calculate walk run blend. This uses a gate value. Set gate. So in our character blue, character assets, our blueprint, not camera system, character logic. What is the class of this? Variable character, yeah, passes it. So it's variable type. at this blueprint. Let's just try and find gate. Okay, there's no references to gate. Get BPI current state. Oof. I want to figure out how they're figuring out that gate, because that's a very important part. And how it does that, I know not. Maybe if I go into here, there'll be some references to gate. Aha. New actual gate. Functions are a great place to perform logic based on the previous. So, does the gate change on speed? Because that's running. That's sprinting. Walk. Oh, so I think gate is just a like actual set thing. Rather than calculating gate based on speed, gate is just a set thing. So I think we don't even need walking. We could just have running. Right. That makes sense. Gate is just a walk. Okay, let's have a play. So this main pose of walk run is going to be converted over to this, which is actually we are going to be on controller, so we do need to think about slower movement as well. We'll figure that out in a second. We'll figure that out later. So let's create these new blend spaces that they use. Because I think we've got all the animations that we need. So if we go to locomotion and we create a new animation blend space 2D, and we call this BS loco forward. No, for Edric's skeleton. BS loco forward. And it's going to be from 0 to 1, 0 to 1, 1 segment, and 1 segment. And this one is going to be walk. How do they set up? Oh, on everything. Walk, run, and stride. Yes. This one's stride. And they're both 0 to 1. Okay. Let's move this out of the way. We'll state machine, which is walk 8. Entry. This can't be this. Actually, no, we do want it to be in theirs. This goes into cycle blending. Directional states. We can just do this. Okay. Change this to forward. Rename this thing to directional. Okay. Forward. I'm going to bring in this blend space we just made. So asset browser. Yes. Okay. Forward. Now we need to figure out stride and thingy. So for stride, we'll just do running for the moment. Stride 1. Our walk run will be speed. And we're going to map range clamped. So our in range is 0 to 400. And it'll be 0 to 1. Remap that to our walk run. File save. And then we can create some. So, run forward there. Walk forward there. Do I have the poses? I don't have the poses. I have all the original animations. FP. Don't have all the. Okay, so maybe what I'll do is I will migrate the animations over to this project, the side project, and then I can folder set locos. We just go to this project. I want to test the pose system. Oh, retargeting. I haven't done retargeting for so long. Is retargeting the best way to do this? Or should I actually just create the pose? Interesting one. Let's make these animations. So, our folder that we've made. Animation. Locomotion. So, our walk F and run F. Want to export. Okay. All locomotion stuff. F. Run forward. Export. And Maya now. Make a new Maya file. This is going to be just a series of cutting out content, cutting out information to create a pose of the correct length in the correct sort of position. So if we just bring in each of these two files, animation Let's start with run F. So here we've got our animation and workspace. It's only got 2. Oh, it's because make this. So our last frame, he's 30 frames. This is 24 frames long. Our project, where the feet cross over, where the feet are the closest together is where we want to create our pose. So frame 6. So frame 7 to 24, 8. Frames 5 through 1. Is there a 0? There is a 0. We need to delete it all. Fake. So now we've got... Wait, I just deleted all the keyframes and somehow... Oh, I didn't delete it. Now, nice, that's exactly what we wanted. Now let's just select all this. File, export selection, animation, bake, N20. Click over to this folder. There's a small. Okay. So this is run F underscore pose. Okay, so back in Unreal now, bring that animation in. Onto Edge Skeleton. Animations. Yeah. That looks right. So now this, if we go run forward pose, but that kind of like crouches down. That's the wrong bit of the animation. Maybe there's more to work than just the... Let's just carry on with the system for the moment. Let's just delete all this. Do it to the... Well, bring the walk. Select bone. Like frame 9. Also the same length. So this is a longer animation. So this is 34 frames. 4 frames long. And delete all. Now we have an X F. Okay. Let's import that animation. Up. Walk F pose goes in here. Now, that's our stride. I think we're going to edit our stride based on speed. I think what we have to do is make it so in our pose position, our feet are actually flat on the floor. I think actually it's better to have, if we put walk F into both. Oh, pace. Run F pose with walk. Now we have 2 walk-F poses. That actually look better. I think that's really nice. That blending will look good, but I don't know if any of this is actually going to fix the problem we were having. So I guess we'll just figure it out. So at the moment, stride is just set to. So let's go back and see what happens when we walk forward. Wait, why is this working? Ah, it's because I'm only doing it for the Edric arms. This actually has to be done on Edric legs as well. In fact, Edric legs is probably important. Yes. Okay, so animation. Let's get up Edric full body animations. Go over here. We need to find everywhere. Base movement legs. Idle run. Moment it's just go to base movement arm. That also have the exact same blend space. Yes. So what we're going to create is a new 8. I name this run walk run go. We will cache this pose. Cache pose. Whatever, like that. Dyslexia. Don't knock me. So instead of this, we'll use our run. And in our base movement arms, so they both now use this separate thing. So idle run. Go back. This be add state going to be forward. In this state, we're going to add our BS loco F. Fine. Walk run be based on. And our stride is going to be. Now let's see. Why is that? The leg. Controller's a bit granular. Hopefully I'll be. I need to test both, but slightly better. If I walks forward very slowly. Oh. After I've plugged in the controller. I think. Oh, I don't have control input set up on this character. Let's look straight down. Why is that going straight? Ah, it's because I'm not lerping the speed. That'll be why. That'll be why. So in Edric full body, it's not actually speed. That's wrong. We need to copy what we did over here. We did some stuff. Did this here thing. Value, out value, file save. Not a big fan about how look down and we walk forward slowly. Yeah, it looks nice. But did that look the same before? Was that the same as before? So if we go back to our main animation graph, base movement legs, idle run, plug this back in, did that look exactly the same as it did before? Is there any difference? If I walk forward. The arms actually, I think, don't look quite as good as they did before. This is what I'm trying to fix anyway. This is all culminating to fixing a different problem. So stop sweating the small bits, Tom, and focus on fixing the bigger problem that you actually wanted to fix. Getting distracted by small details already. At the moment, for our upper body, we probably don't need this at all. We could probably just use this. Because the hands were looking a bit odd before. I was just doing that a second ago. Now, actually, no, that looks fine. It's just I wasn't used to seeing. That's all working. Okay, so let's add the other directions to see if this system works. Because none of this is going to matter if the directional stuff doesn't fix the legs flipping around stuff. So this is all highly theoretical right now. So let's make our poses for all of our other walk and run positions. So we've got forwards. We need backwards, left back, and run all of these. And let's oh no, we have to do this with crouching as well. I don't know. Run backwards, left back, left right, right back. Asset action, export. We don't need to bulk export. We can... Not that many assets. Could export it by bulk and you save a couple clicks, but I think we're more likely to cause problems by doing it as a bulk. It's only like 10 clicks. I can deal with 10. Okay. So let's just run top to bottom. Let's get all these done. Let's do this process to all. So run backwards, bring it in. This is 20. It's only 20 long. A different length than. A different length than the run forward animation. That's weird. Why is it a different length to the run forward animation? I thought they all had to be the same so that the feet matched up. Or are they doing actual foot matching with like... Oh, God, that's going to be complicated. Okay, we just push through. We push through. Okay, so let's select all the bones. Figure out where they cross. Where's the best place for it? Like 4. Nice. File. Selection. Run back. Underscore. Pose. Did I do capital P? I did capital P before, so. It was nice when it's so run B, run F, run LB. This. Bones. Check the length of the animation because it could be very different for each single one. No, 20 again. So, where are the feet closest together, but not crossed over? 4 again. think they're probably all going to be neat. Run LB. Forward. Four again. Oh wait, this is a longer animation though. So the run forward stuff is 24 frames long, and the run backward stuff is 20 frames long. That's not confusing at all. Oh. Get out of the screen. Okay. Left forward. Maybe this has been the problem all along, that the animations are different lengths, not any sort of systematic thing. I really hope that's not the case. If that is the case, I have to look into foot matching, which is going to confuse my brain. It's going to really confuse my brain. I exported this, right? Got this one. Yeah. Delete. RB and RF. Our running's done. Then we need. So this is back to being 20 long. And frame 4 again is what we want. Frames. RB. Pose. Racing Bulls. Increase this to 24 now because we know what we're going to have to do in a second, which is bring in forward run forward. Thanks. Not run forward, right forward. Don't get confused between R for run and R for right. This will be on frame 6. Or was it 5 that we used? Frame 6. Okay. We might at some point need to edit. Oh god. Oh, run forward. And now walk backward. We didn't actually need any of the run poses. Oh, we've got them now. So use the walk pose for both on the forward and it looked better. Okay, so from the side, when are our feet most together? 7. How long is this one? 34. So, what? Oh god. What frame do we want? Frame 7. So, frame 0 to 6. 8. 8 to 34. Delete. Nice. Action. Walk backwards. Pose. Left back. Same length. Yes, it is. So what's the closest position? Will they cross over? 7 again. 8 to 34. This timeline can be really awkward. Like stuff on times. Section. Left back. Equal that. Forward. This the same length. It is. Okay, well at least the walk poses are all the same length. That's some small release. So this actually crosses. Closest point before crossing is actually more like 11. 7. Might use 10 actually. Crossed a little bit too much. 11. Equal this. forward, pose. Right back, yeah, right back. Frame 7 again. Right back. Frame 10. Okay. Anymore. Let's grab all these things. So pose, 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 pose. Forward, we got it. Pose, pose, pose. Import onto edge skeleton for all. And we create a series of blend spaces for each of those. If we duplicate our loco to loco backwards, loco right back, duplicate loco right forward, left forward, S loco left forward, again PS loco left backwards, and that's all of them, I think. Okay, so loco backwards, gonna need to run up walk B, walk B standard, and then walk B pose. Save. And now run backwards, backwards. Little stride, little stride, little steps, little steps. Those big steps. Nice. I just need to do that to all of them. So left back, run, B, walk, B, LB. Run, LF, LF, walk, LF. Right back, E, RB, RB. Run forward, right forward, run, RF, walk RF. No. File. Okay, Edric body. Walk run cache, walk run Roco. So here we need a forwards, backwards, left, backwards, left, forward. Girls, forward. No. right, backward. Okay. So let's look again at the system we're basing this on and see how they do their calculations for. Because this is now what I need, the movement direction enumerator, and how do we figure out this? So if we find references, set movement direction, calculate movement direction. So it basically just bases it on a threshold based on velocity and aiming rotation. The velocity and aiming rotation, which is just like, I'm assuming just the camera forward. Find references. The aiming rotation. Great, okay. Cool. So back in our event graph, in get base movement, we've already got velocity, and we've got speed, and we have forward rotation? I don't think we do. So let's create another little, let's just do this as another sub graph. So, we need to get velocity, this value here, and then we need to rotation from X, and what else do they do? Delta, okay. Delta rotator from, then we'll get our character, and we will find our wood. We need to figure out our rotation. What's our look forward rotation? Get camera or get roll rotation? I think that's what we want for that value. And then we want to split this, and we'll just print out the value we get with the moment. Print value. This should be like what we use for our input. Okay, that's not quite right. These shouldn't change as I turn around. So they're doing it right where it's saying 0 is forward, minus 180 and 180 is backwards, then minus 90 is left, plus 90 is... That's all working. What's not working is as I turn around, if I'm not moving, those values are changing. Then they go back to being correct as soon as I start moving. So maybe it's fine. The fact that they are wrong when I'm standing still, because I don't need them when I'm standing still because I'm not walking. Only when I've got movement input does that matter. Of course it wouldn't work because you don't have velocity, right? Or am I copying him? Am I copying? Copy? So now we need to create some thresholds. So do they use any? Okay. Create a function. Do it as a function as well. Get movement direction. And are we going to do it as an enumerator? An enumerator is probably the cleanest way to look at it. So let's create a new enumerator. So our animations, we'll just create an enumerator here. Enumeration, a movement direct. Underscore. We need forward, backward, left, forward, right. Right. Oh, they only use left and right. Weird. Why do they not use that? So how do they figure out the... So going between... So this is like, if you're moving left, go towards this way. I actually quite like that system. That's quite cool. So what they're doing is when you're moving backwards and you start moving left, you go into a left back position. And then if you keep moving left for long enough, then just move left normally. So let's just see how this looks when I'm on a controller. So I move backwards, I move backwards. If I move left backwards, left backwards. As I move further and further to the left, it switches forwards. That looks more natural. Okay. I think we won't use that system. As much as that system is quite cool, I think we'll just use an enumeration system for all the direct, which could be interesting. So what we need to do is actually like an in angle. So angle. And we're going to put the thresholds on the... I think it's going to be clean if we do the thresholds inside here. So actually no, forward threshold, back threshold. I think that's all we need. All we need to know is like you're moving. So when you're moving forward, you have threshold. As you move right, threshold that you. How does this work? I'm very confused. It's like, oh god. As I move forward, and I move this way slightly. Fusio. Okay, let's do their system first and see if we can improve upon it. Let's recreate first and then figure out what we need to do. So FR threshold, LR fresh, right back threshold, LB, and then create a buffer. I assume that we use that buffer for something. So angle in range. Okay. So angle in range. Is this a custom function as well? Oh my. What does increase buffer? Let me just unpick this a bit. Bin. Oh. Okay, so we need a new function. Angle in range. Good fun. So what we need is angle, min angle, max angle, pass through the buffers. Let's just do this. I still don't get what increased buffer does. So if you increase the buffer, what you're doing is you're minimizing. Basically, if you are increasing buffer, you're using the. If we just copy these bits for a second, see what it looks like when I copy. Because I just don't think that I want the increased buffer version. I don't think I want the standard one. So max angle plus buffer and min angle minus buffer, that is within the range. Then that's what we need. And then we need one output, which is a Boolean saying in range. Then that's all we should need. I think. Hit movement direction. Angle in range. We need to get our angle. Amp angle. Get angle. Okay. Oh, they're not using a function. They're using. Oh no, it's a function. Or is it in macro? It is. Yeah, that's fine. But it's a pure. It is. So. Convert to pure. Because they don't have pure function for them. If we go into this function, go here. No. Okay, that's better. So first we need to figure out, should we move to the right? So our minimum angle. Oh god, I'm already. So front left, front right. FL. Left is minus, right is positive. What have I done here? I've named these things the wrong thing. FR, FL. I've done a left, right. Oh god. So this should be FL. And then back, right, and back, left. No. Left back, right back, right forward, left forward. So LF threshold and RF threshold if this is true, then we're between these two, then we're moving forwards. First branch, these two are true. Set our movement, we're using variable, which is direction. We're going to set it be forward. Okay, if that's true, we're going forward. If it's false, but we're between so we need another branch. At the moment, actually, our numerator is wrong. We want actually to have so delete, and it's just left. If we're between front, left forward, and left backwards, then we're moving right. So we need another one of these with another angle and buffer. Let's get RB threshold and LB threshold. So if we're between left forward and left backwards, although left backwards is going to be a big, smaller angle. So left backwards is actually a minimum. This is a maximum. Because left backwards is a bigger minus than left forward. So yeah, that's correct. If that's true, set movement direction left. False. That's not true. Then check that we're not moving right. Be between right back and right forward. So right backwards is going to be the minimum angle. Right forward is going to be the maximum angle. This is now positive again. Or is it? Because right backwards is actually a bigger angle. Because it's it's going to be between 170. So maybe it's the other. Yes, it is. That is correct. And then if that's true, right. And now how do they figure out backwards? Also, if just one of those are true, you're moving back. Well, that's false. I actually want to do that. I want to say that if so if you're less than, if angle, actually let's just do how they do it. Copy and then adapt to your situation. First, we need to create a system that works, and then see what we want to. That's all fine. So our idle run state, that's fine. Our walk run. Okay. So if we want to go from forward to left forward, left forward to forward, and in transition, movement direction equal forward. Okay. But on theirs, though they do go through the middle. Okay. all of them can go forward. Backward. Wait, can that? This one can't get to that one. So oh, interesting. Okay, I like that. So this also goes back, left backward goes to there if you're this one goes here if you're going. That means it sort of slowly transitions from a left back to a left. Have blend times. Yeah, quite long blend times. 5, 7. Yeah, these are all quite long blend times. Maybe that's how they figure out the lerping. Okay, so this one then goes to here if we're going backwards. Backwards. Copy this. This goes to here. Going backwards. Here. Going backward. This goes to here if we're going backwards. My brain is starting to feel fried. Animation systems always make my brain fried. It's so convoluted for no good reason. Well, apparently there's a good reason because I'm trying to improve it. And then forward to left forward is if we're moving left. Left. Copy this. And then backwards to left backwards if we're moving left. And then this way is moving right. Right. And now we need to figure out what we do in the middle. This goes to here if we're moving. So what's going to happen in the middle? So left backward goes to left forward. We're moving right. What if we go this way? Right. Why would you not transition to that? There must be a good reason for it. Let's try it out. So left backwards goes to forward right if we move right. Left forward goes to right backwards if we're moving right. Right forward moves to left backwards. We're in already. If we're moving left. Honestly, talking out loud is very helpful in this because I don't know if I'll be able to do this without talking out loud. This one here, if we're moving left. Let's just see how this looks. I'm expecting this to go horribly wrong. So if we move forward, that's right. If we move backwards, that's right. If we move left, we go forward. If we move right, we go forward. So no, that's still using. Have we even hooked up the? If we go into here, we haven't hooked this up to anything, of course. So we've got our get movement direction. Yeah. This is what we didn't do. We need to hook this up to here, and we need to figure out our yaw here is the angle. Our buffer, let's say that's 5 degrees. So let's just see the values they use first before not getting too crazy. 70 and 110. Okay, so right forward is 70. Right backwards is 110. Left forwards is minus 70. And left backwards is 110. That should fix the fact that it did nothing. That's always a good start. Make it do something. Forwards, backwards, left. We haven't put poses in. Am I being silly? Pose. Ah, we haven't put our values in here. That'd be why. So we need to get this. So left forward, walk, run, 1. Left backwards, 1. Backwards, 1. Backwards, 1. Also, forwards, let's increase the blend time on these. I think the blend times are quite short. The system is mostly working. You just select all these blend times. And put them up to like 0.8. What is the blending they actually use? Cubic 8. They don't use any. Blend profile is change direction. What the fuck is a blend profile? Oh, okay. No idea what a blend profile is, but we'll figure that out. Okay, let's look down at the ground. Okay. This is starting to come together. We've still got a lot of stuff to edit. Because right now there's no way to go from left backwards to left forwards. So when you come out of right forwards and you move left, you go to this, but you need to then return to this after like 2 seconds. So like we need to figure out at the point of go from left to right, like set a value saying left to right. I'll start going forwards, if you get what I mean. But what if you're actually moving backwards? Haha. Can't even this all out a little bit. Even here. Why does mine look so ugly compared to theirs? Theirs is so neat. I guess because they emphasize words and stuff or whatever. It's fine. Need our graph to look neat. Or neater than this. This is neat enough. Okay, so what don't we like? Let's edit the blending first, because definitely more we could do with the blending. Select all these. Let's reduce this down to 0.6 cubic. Let's do Hermite cubics. I think that's whatever it is. I think that's slightly smoother and nicer. Down the ground. From backwards, from forwards, then backwards, then forwards, backwards, forwards, backwards. That looks quite nice. Then let's left, right, left, right, left, right, left back. Okay, let's hate all this crap. Running into stuff right now. Oh. Create an even bigger space. No. I'm just hating too much stuff right now. So, woods. So right now, our backwards values are too high. So let's print out some values, start analyzing what's going wrong, what's going on. So if we get this value and print out this yaw value that we create, because this is the value that basically controls everything. So we need to have a good understanding of what this is doing, how it's changing. At the moment, it's 0, minus 1. This is minus 135 and 45. So if we're saying that this is between minus 70, we're forwards, and if we're not between minus 70 and between left back, why are we never moving left? Let's also print out the let's go to our print. So let's print out this value, and we will make this last 0. Then we will then append. So get this, and we'll append space dash space, add pin, and we'll get our movement direction and print that out as a string. So we're 0, 0 forwards right now. And then we are 180 backwards, 90 right, minus 90 left. So the values are correct, but when we're going minus 90 left, 90 right, minus 90 left, 0 forward. So in our 4 quadratic sort of movements, 4 backwards, left, right, that all works nicely, actually. It's when you try and go in the 8 move, those diagonals, that we got to lose where we should be. In a 2-minute back in my head with what I'm doing. Correct. Okay. So how do they move forward? Oh. So the forward pose is actually not just forward animation. It's also desired alphas. So blend, velocity blend, find references, set velocity blend. Calculate velocity. What the hell is this? Local relative velocity direction x plus sum divided by that relative direction. This makes no sense. So what they seem to be doing is, at the moment, what's happening with ours is we are we're coming into forward, and then we're never actually getting to left forward. But I think we can just increase those values. Because the problem is that in forward mode, we're not getting any lerp left and right. Because what you want to happen is when you're like running forwards, don't go full left post. Want in forward, you want to blend a little bit of that in. But I don't think I like their system. I think their system's too much for what I need. I think I'm just going to, on the forward, I'm going to create a forward, a backward one. But the problem is that I'm going to get to the same issue that on the backward one, it's going to do like the weird flicking around thing. Because in Unreal, when values are minus 180 or positive 180, they get really confused. So that system wouldn't fix that. What was it? So, because this forward to backward looks nice now, and forward to left, forward to right look nice, and like left to right looks good. But then we need to have a thing where you switch your hips over. And this like walking around in circles business doesn't look bad anymore. So we are getting much closer to what we want. We're getting there. It's getting real close. But we just need to figure out some more bit. The first thing we need to do is create another system of going from left to backward. From like the left foot to the backwards to forwards movement if you've been going in that direction for long enough. So what we need is a we basically need like a Boolean, which is saying hip bias left or right. So let's just imagine this. Hip bias Boolean. So if it's like hit bias right. So if it's false, not foo, then it can go into this one. If hit bias let's hit bias right, a new hip bias left, bias right. Let's get our hip bias left. If it's true, it goes that way, and on hip bias here, there we do hip bias right. Get right, and we will set their blend times to like 8.8. Both of them start out as what did I press? Why are these all the wrong color? What's happened? That was weird. Why? Oh, so I can't drag them in here. Okay. First left, default volume is false. Default volume is false. So now in our get movement direction, when we set our movement direction to left, we need to like call a function, which is like it's like now start trying to set my hit bias. So let's on our event graph create a little function event, which is update hip bias, and then left so sequence. If it's left, do one thing, right. I don't really like using two variables for this, but I think it's going to make it much more readable when I come back to look at it in a week's time. So if it's the left hip, what I want to do is so if we've just started moving right. Is this even slightly what we want? Oh, my brain. The left, we want to set hit bias right. False. And then hit bias left after a reasonable delay of, let's say, 0.5 seconds. That hit bias left to true. We'll do the exact same thing, but reverse on the other side. So here, we want to update hit bias. Do once. Set it I'll move forward and backwards. Same thing for here. We'll reset it on forward and backward. Don't want to call time. Once. This is right, this one left. So now, right, left. Ah. Also need to reset it on the other one's time. So, wait, no, it's not. Oh. That. I think we also need to do this and reset the other one on your hip. I think this will the thing and then now move left or working over. Oh, move left, backwards, right. Check the hit bias. Right, true, yes. Bias. Oh, I was setting them both to true. That's work. So move left. That all works. Stop moving right. Why didn't you work? Ah. Okay, see if it works the other way around because I think it's the other way around. So left, right. Oh, didn't work. Okay. Why didn't reset it? I move right, left. Let's print it out. If in doubt, print it out. That's what I say. So we'll another print string that we just get bias right, bias left. Little append. Two of them. Yellow. We'll say right. Hit bias right. Is that true or false? On at left. Bias left. True or false. We'll be able to see if there's something weird going on. Oh, it's not working. So both are false. We go left. Wise. Oh. It's only getting set true when I stop moving. Why is that? That's good. At least it's not working the way I wanted it to. So if you set movement direction left, do once, set left true. Is the problem the retriggerable delay? Let's take out the retriggerable delay for the moment. And just make it instantaneous. So that works. When it's instantaneous, it works. So if I move backwards, oh, my text is full screen. Whoops, yeah, I left it on. Why? Why is that not? Is that reset? It's a do once node, so it should just call it once and not reset itself back to nothing. Why is this retriggable delay not working? It has to be a retriggable delay. It might happen again. But clearly the retriggable delay is getting called over and over and over again for no reason. So why is that? Retriggable delay is outside of this. Ah. It's because the do once is inside of a function. And the function is recalling itself every frame. Still working? Still alive, or have we died? 5 to me. Ignore that. Ignore that. Ignore that. But anyway, so we could either convert this over to a standard event and not use a function. It means that all these have to be variables. A bit annoying. Or we could use some sort of system of actually checking like when you press left or right. It's an option, but I don't like it. Or what we could do, I've got a new idea. We plug these straight into here. On this, we have a do once. And then we have a new custom event, which is reset hip bias, which is setting them both to false. Both to false. And then reset the do once. Like this. Start closed. We won't stop. And then in our direction, we will call reset hip bias. Forwards and backwards. And we'll also reset it when you move. We won't reset it when you move away. Yeah. Moment we'll just. So now. Yeah, that's nice. So now, like, if I walk backwards, then I walk left, I walk backwards and left, and then I switch over my feet. So I just need to increase the delay timer. Here, in my up the hip bias, in my reset, my retriggable delay, let's make this like 1.5 seconds. And then that should look a bit more pronounced and nice. So I move backwards, and I move left, backwards, then left. I switch over to here. Backwards, left. Yeah, that looks nice. However, we've still got the issue that if we move forward and then right, so I'm gonna put a texture on here. If I put the grayscale, it'll work better. I need to be able to see like the floor texture. Am I in assets? Do I have a grid? I swear I made a grid. Why can't I search? That's annoying. Let's just got a file. tile pulse. That's ugly. Aha. Here. Concrete tiles. Standard concrete tiles. We change the UVs. Let's make this like increase or decrease this. Make this 10 and 10. This way we can actually see the floor moving and it makes it much easier to see working, not working. So left, right. Okay, so this still needs a bit more advancement in its system. So, so we have a full reset of this. So we can reset right separately. And we need to create a couple more functions. So custom event, set hit bias left, and then custom set hit bias right. They all want to be zeroed out? I don't know. Yeah, see if this works. It's like, you know, ask forgiveness, don't ask permission. See if it works. So we move right. That all works. And left. And you actually call the functions. That'll help. So when we move to the left, we need to reset hip bias left, and here we need to reset Oh, why didn't it work? Need to be the other way around? Go to here. This needs to go to here, maybe? Or is the whole system flawed? That's what we find out after the break. Okay, well, it doesn't seem to work at all now. The biases are not being set at all anymore. Let's take it back to the bare bones. Let's not delete everything. Unhook everything. And get all this out of the way. So this is getting way too confusing. So we need to update our hit biases. So when we walk right, set our hit bias to our right. When we go to the left, hit bias to the left. If we do go backwards, we'll bias to none. So for the moment, reset hit bias can just be this. And we know that we want to do that when we walk backwards. So reset hit bias, when we walk backwards, we know we want to do that. When we walk forwards, we know we want to do that. When we walk to the right, we want to it's destiny. So custom event set hip bias set hip bias F. I don't like how many events this is. This is so many events for just like the base walking. Set hip set bias right, not righty. And we need to figure out a way of resetting these. When we set our hip bias right, this needs to reset both of those. And then I also think that each of these need to reset the other one. So it does its thing, and then it resets the other person. The other person, the other hip. Does its thing, and then it resets. I think that's much cleaner than what it was. So delete all these. Set hip bias left. Set hip bias. And now we move right. Our right bias is true. Move left. Okay, have we got into a situation there where they're both true? That can't be right. That doesn't look great. So now we need to figure out. Let's do a quick gate setting system. So in our event graph, over here, we'll leave all these print strings for the moment. Base values, our speed. We will also use this to set our gate. Set create a value gate. Float. Set gate. Speed. Greater. If it's greater than 200, then select float. So if it's greater than 200, it's 1. If it's less than 200, it's 0. That just sets up gate real quick. And then our walk, run, loco, and all these, they need to have gate as a value. Is it gate or stride? Let's rename this to stride. Stride. And this way, when we're walking slowly, we get our walk animations rather than our sprint or run animation. Hopefully. Hopefully. Now, on the controller, if we move slowly to the right, below a certain gate, what's happening? This. If our speed is like 0.5, our stride Okay, I got the values the way around. Okay, that's fine. So what I need to do is stride and gate. You need to switch around on all these. So it is actually gate. Stride. Gate. Gate. I'm not going to finish the system today. I was really hoping I'd be able to finish this system today, but I'm really happy that came along actually. I was expecting it to be harder to do the first section, but I'm glad I went down the procedure, because it being procedural means that no new animation work. The system I was originally going to plan to do would require loads. So okay, so we need to lerp our. Okay, so that's not right. We need to setting our thing so abruptly. Cool. No. Up. Map. No, map range clamped. Oh, the map range clamp I've used so much today, and I don't know how performant it is. I'm kind of scared about that. So this is the alpha. No. So between 0 and 300, I go from 0 to 1. Okay, so there are aspects of this that I'm really liking. For a second there, I had all of them as true. That's not right. How did I get all of them as true for a second? Okay, so I managed to get them all true. Is there a way to... When we hit set it left, we also want to make sure this always set hip bias right to false, set bias left. Actually, let's put this. So after that, before the do once, want to what we need to do. Make sure we're setting the other one to false all the time, and we only set the setting of the true is based on the do once node. That should stop any situations where both are setting to true. Whilst that didn't actually cause any animation bugs, I was concerned that it would. So left, then we switch over to right. Got our hips over. We move backwards, we move forwards. So now it's this diagonal movement that's looking wrong now. So what we need to do, I think, is inside of this forward and backwards, we need to create some kind of blend space for the 3 directions so that we can have the Edric back, Jimmy forwards as he moves around. But maybe I leave that for another day because brain's kind of. How would we do that? What's the best way to do that? Do we create 3 things here that we then lerp based on angle, or do we create a blend space? I think we create 3 things. So actually, let's just, if we are forward, get our acid direct, get left forward and right forward. Blend float. Oh. Then blend poses confer that. Can I add? I basically want to create a blend space between these 3 poses. Oh, I could just do this. Can I do more than one? If we just, for the moment, tried 8, tried 8. If we just say we have B, A, save, make 2 of them. Oh, this is looking so ugly now. 2 forwards, tried, 8. Blend between these 4 things, and then another blend between these 2. This is now a 3-way blend based on movement angle. So if we print out our movement angle, all this is fine. This is all working now. So let's delete all this and print out our. I want to figure out what values I need to use. So forward, it's just between like minus 110 and 110, and it's positive. Backwards is going to be difficult. Not looking for backwards. Backwards can bet you. So if we get movement angle, we remap. No, map range clamped. So in range is minus 70 and 0. And out range is 1 to 0. Here is 0 to 70, and then at 70, 0 to 1. And then another one of these for this one, which blend these 2 between minus 30 30, 0 to 1. Let's see how running forward looks now. Give ourselves some space. Round. Forwards. That's not. Getting somewhere. But our range mapping is just between minus 90. Maybe even more. Maybe it's so just a little bit, and when you go full right or left, it changes. And this will be between D and actually, this one should be minus 70 to 70. Minus 70, 70. Play. Now, run around. Get a little bit of movement here. Over. Okay, we're getting some issues obviously when we're going backwards because we don't have blending issue. But on the running forward side, I'll say running forward feels pretty good. I'm scared about that, like there's a jump going on somewhere. I'm just scared about what that is. I'm trying to see if I never go backwards, does it ever do that jump? Okay, it's stopping. Stopping it doesn't like at all. Oh, so because when I'm stopping, my movement angle input's like 90 something. So let's actually, when we're setting our movement angle, find references. When we set it, I think we should only be setting it. We just create a quick sequence. So our movement angle branch is velocity is speed greater than, let's say, 100. If that's true, then set movement angle. But then now the movement angle should never get set below. And then what we also need to do is set it. If this is false, then set movement angle. Then now if we're moving right and we stop, get set back to 0. Right again. Okay, there's still some snapping going on when I walk backwards, but the rest of the movement angles work pretty well. We just need to implement a system for moving backwards, and then I think we've actually fixed the last thing we wanted to fix on this. The where's my yeah, the hip and leg stability. If we fix the backwards hip and leg stability, like nice, and then we're ready to review the system and then implement into the main project. Ooh. I think this addresses all the issues that I was having with the first-person system. Oh, okay. So we've sorted out our movement angle stuff. Cleaner. I don't know why I'm cleaning up blueprints when it's in a test project and I'm going to have to redo it all in the main project anyway. But what can I say? I'm OCD. How's it going? It's going good, actually. I've had a very productive afternoon of information system. I've converted our true first-person system to sort of a fake first-person system, which has been going really well. And then now I'm just doing some hip stability stuff to improve like camera shake. Because the camera is attached to the bones, when you walk around, you get this issue of like this sort of, this jerking about the camera, where these like you can see like flickering. And it was much worse before, but I've just been changing how our walking and legs work to hopefully fix that. But right now, what I'm trying to fix is the fact that when I walk backwards, even if I'm walking backwards diagonally, it's just the walk backwards animation. So you get this jerking. I'm trying to fix right now. But I just implemented a system for forward, this system here. So hopefully that'll be fine. That'll all work. So what is next to do? Next to do is create a system like this for walking backwards, which is going to be harder because Unreal hates it when you transfer between -90 and 90. I think that'll be fixed by this system I'm doing, actually. I'm converting everything into 0 to 1 space. Okay, so let's first copy these things, this, into my backward state. So I get this. Then loco backwards. I need 2 of them. Cool. And they have the stride and they have our gait values. Then we need back left backwards, right backwards in here. Plug all these values in, all this stuff in. Then we need to figure out our values. That's good. And this, yeah. This goes in. Yeah, this goes in. Yeah. So, first off, right backwards is between like 70 and 180. Left backwards is between not 0, it's between -180 . Is that right? -180? Or is it between -180 and... Did I do left at the top or right at the top? Oh, left forward, right forward. Left backwards, right. Right around. -180 and -70. Delete this. Plug this into here. So this range is going to be the tricky one because now we don't want to deal with this because if we lerp, actually maybe range clamp will work if we go minus what do we say? -70 and 70. Well, no, it's not. It's minus 135 and 135. Let's see if that works. I'm scared it won't work. Now we move backwards. Yes, that's not working. That is very much not working. Oh dear. Okay, I need to think about this. So, when we are moving backwards, which is 0, be 0. And 0 here, actually 180. This is 70. That fix our just walk backwards? Yes. Oh god. Yeah, this is the problem. As soon as it's exactly flicking between minus 180 and 180, you get real problems. Because if I walk directly backwards now, it doesn't know which way to do it. Because it's like, oh, but I'm not actually, I'm like minus 181 or possible. So let's just do one of these for the moment. So we just care about left backwards and backwards right now. Let's check that side's working correctly. So if we look down and move backwards, to the left. No, that's not working. Is that the wrong way around? Minus 70, minus 180 instead. So yeah, so the left side is working correctly. The left side is working. Now let's test the right side before we start trying to blend the left and right sides together. If we move right and we start moving backwards, okay, the right side is working as well. Now we need to figure out the blending between the two. Betwixt the two, we must blend them. That's this one. Yeah, that's not working. So, how do we do this? We need to blend between these two. Maybe we just do I've got a silly solution. Blend bool. So if our movement angle is less than minus 170 and greater than 170. False. I don't like having so many of these same things. There should really be a hashed pose. Fix that post. I really doubt this is going to fix it. It's as soon as it goes from that minus 180 to 180, we just get a big jerky blend. Look at that flick. Look at that flick. Like literally everything forward looks so nice. Even forwards but then like backward angles. But as soon as you go straight backwards to the other side, that looks so ugly. Well, let's have a look at the other system we're copying. Let's see if they have a clever solution for it. Where am I going? Like a relative to... This velocity blend stuff is obviously important. Ah, they're normalizing it. Okay, I just need to normalize it. And I just need to use my enumerators to figure out whether I am going left or right. I think I can do that. So, for example, if I get my... Rather than using movement angle, I use a normalized version of movement angle. So, if I... don't use any of this. If I blend poses by bool. Wait, no, because the movement angle is always going to be backwards. Get movement angle. Less than this, like 3. It's less than minus 170. What is this going to change? I've not changed anything. Yeah, I've not changed anything. I'm just making notes. Okay, I'm going to stop, have some food, take a break, and figure out afterwards. Hope anyone who's watched this found something useful. And I will see you another day. Look. Make sure to check out Project Grow, wish list and that sort of stuff. I will see you in the next one. Once I've figured out how to do it. My brain's hurting now. Can't do that. But yeah, I will see you all later. Have a good weekend.